Hi everyone. Today in this video I wanted to talk a little bit about planning for your teaching in senior mathematics. Now I know you've done a lot of work on planning already in general areas related to your teaching career, and you've also done planning on your practicums and things like that. So I just want to talk some ideas, and then you might be able to apply them for different things with a particular focus on senior mathematics. So some general points. As new teachers, you already know how to plan a basic lesson in a traditional standard form. When you go on prac, I'm sure you were given some templates and things you had to follow. Also in all of your earlier courses and some of your prac courses, you would have talked about planning in general. But planning in senior maths can be complex, and particularly when it addresses all the curriculum demands. It's conceptually dense mathematical ideas, and it's content heavy. There's lots of things to cover. So what's important is we need to make sure we're always learning driven and focused. Now what I mean by that is you can teach all sorts of things, but it doesn't really matter, because what's important is what the kids have learned. You're only there, your job only exists because people are learning. So rather than thinking about what am I going to teach, a better question is, what do I want the students to learn? Now it might sound like the same thing, but I can assure you that often some of the things you think you've taught are not the same as what the kids have learned. So some features of good planning. Well, the first thing I'd say is it starts with conceptual development before practice. So you need to develop some understanding of what you're practicing before you go away and practice it. Now I'll give you an example. I tried to play golf for a while. And I went along a couple of times and I quite enjoyed it. So I went out and practiced. I did a lot of practice. The problem was I was practicing my mistakes. And then after a while I said, I enjoy this golf, so I'm going to go and get some lessons. Well, the first thing the golf pro had to do was to unteach me all the bad habits I've learned before he could reteach me the good techniques. It's because I'd practiced before I knew what I was doing. And sometimes, particularly with complex ideas in senior maths, we get students to go away and practice their ideas before they really understand what they're doing. So make sure you get a good conceptual understanding first before you give them the textbook and say, go and do the exercise 7C or the odd numbers or something like that. There's nothing wrong with practice, but practice comes after you understand what you're doing, not it doesn't precede it. Because the other thing is, practice makes permanent. We always used to say practice makes perfect. Well, it doesn't. If you practice mistakes, you'll make perfect mistakes. Practice makes permanent. The other thing about planning I think is important is when you teach, you spend most of your time asking questions. That is your main pedagogical tool. So you'll plan activities, you'll get the kids to move in various spaces to do things, but then you'll ask them questions. And it's actually the questions that are designed to help them think and learn. Now what we do when we plan our lessons and units as often as we plan all the activities, what the things the kids are going to do, but we don't plan the questions. And the questions are the very heart of the learning part of it. So I suggest you really think about the questions you're going to ask. Otherwise you'll probably tend to ask low order recall type questions, and you won't develop that deep thinking about some of the ideas. Here's a little model. It's nothing particularly fancy, but often we want students to learn the mathematical context. We start with that ellipse at the top there where it says mathematical context and ideas. And if you look at your textbook activities, you know, the first 10 are practicing these things, and then the last 3 are the word problems where they apply it to a different context. And what we find is sometimes kids can learn mathematical concepts and ideas, but then when it comes to apply them, they've got no idea how to do it because it's a completely different context. Now my suggestion to you is, wherever you can, rather than starting with a mathematical concept or an idea, start with a problem in a context where they need that idea. And then once they've worked at that problem, then you generalize the mathematics out, and then it's much more readily available to be applied in other contexts. So traditionally we start with the top ellipse. I'm suggesting we start with that on the side there, a mathematical problem in context. So here's an example. The initial task is tossing the ball. The students get a general idea about what it is in 2D motion by just throwing the ball up and down. check for understanding. How could we describe this motion in 2 dimensions? So do this throwing a ball straight up and down. You know, what could be an advantage to use vectors or calculus? Predict how we might calculate the acceleration. And then after that we've done those things and developed these ideas of acceleration or vectors or what happens to be the topic, then generalize the mathematical ideas and then get the students to practice out of a textbook. And then when we do the conclusion, we let them go back and try and apply it to other areas and have time to revise. Another activity is one I call the nest egg. And this appeared in the paper quite a long time ago. You can see there that it shows a series of eggs decreasing in size. And the question, this was from a superannuation company trying to get you to invest in your retirement. And the question is, what would happen to your nest egg in 20 years' time? And at this time, I just gave it to the students out of the newspaper, showed it to them and asked them what they thought. So they followed it up and tried to work out, well, actually, if I had so much in 1990, how much would I have in 2005? How much would I have in 2015? Is it based on the volume of the egg? Is it based on the area of the egg? Or is it a graph and we're just looking at the height? This was an investigation from a paper, and once we did this problem, we could then talk about some of those sorts of things in an abstract way about graphs and newspapers, or if you're from New South Wales, you might say graphs, and how we might represent data in terms of statistics. So that's an example you might see there in a senior maths plan. You might use it to develop an initial plan and then you could share it in the discussion board. My point of showing these things is often if you can get a good task to do that starting point, it gives you then a basis from which to develop your planning. Most of you will be pretty good at planning the traditional sort, which is starting in that top ellipse I have where we say, here's the idea, here's some worked examples, now do some practice from your exercise book. No problem with that. But I'm saying if you can start with one of these other activities first and then move to that, then you're more likely to have students who can apply it to a range of contexts and use it more in mathematical modelling and other situations. So there's a task you can do in your discussion board. There'll be a space for you to do that. Certainly if you develop some sort of plan and put it in the discussion board, then feel free to take someone else's out, or as many out as you like. If you don't put one in, then you're not allowed to take one out. Anyway, I hope that's helpful. Thanks for watching, and maybe I'll see you in class.